Hello everyone, welcome to A plus BI. This channel is all about complex numbers, and in this video we're going to be solving another radical equation with complex numbers. Why did I say another? Because as you know, yesterday we did a problem on cyber math, that's what I meant. This is A plus BI, and that was about radicals too. But of course, real numbers and complex numbers are very different. Maybe sometimes they're similar. But anyways, we have this equation that is very radical again. We have the square root of z plus the square root of negative 4z. Whatever z is, you have to multiply it by negative 4 and then square root it. And the result is supposed to be 1 plus 7i. First question is, can we solve an equation like this? And the answer is yes, right? You should always say yes. Now, if you're new to complex numbers, go ahead and check out my lecture videos where I go over basics of complex numbers and always ask a lot of questions. I also have another channel, Cyber Math, that's cyber with an S, where I focus on real numbers mainly, and trigonometry, number theory, and algebra, just a tiny bit of geometry from the past. You can also check it out. And let me know what you think. So this is A plus BI, which focuses on complex numbers. Let's make that correct. So how do you solve an equation like this one, right? You're probably thinking, because this is a radical equation, aren't we supposed to square both sides? Yeah, I mean, that could probably be one of the ways to do it. So why don't we just start with that? Let's square both sides and then see what happens. And of course, you are also able to isolate one of the radicals and square that way. Either way is fine. I'm just going to square like this, okay? So now, the first term will be z, and then we'll get negative 4z, which is a squared plus b squared. And then 2ab is going to give me 2 times the square root of z times the square root of negative 4z. What do you get if you square something like this? 1 squared plus 7i squared. Oops, I forgot to say that. I squared is equal to negative 1 because I is the square root of negative 1. Again, check out the lecture videos. It'll give you all the basics if you're new to this. So, since I squared is negative 1, this is going to be 1 minus 49, which is negative 48, plus 2ab. That's going to give us 14i. Awesome. Let's go ahead and simplify the left-hand side a little bit. We can go ahead and combine these two things, negative 3z. And then now these two things, can we multiply them? Now, multiplication with complex numbers is a little tricky if you're multiplying them under radicals. Why? Because the square root of a times the square root of b may not always be true if a and b are complex numbers or imaginary numbers, right? So you got to be very careful. But let's just do it, pretend this works. And that should give us 2 times the square root of negative 4z squared. Awesome. At least we're going to get a perfect square. Hopefully, we can take that out. Okay, great. On the right-hand side, we still have negative 48 plus 14i. And you probably want to isolate the radical one more time because we need to square both sides again. So let's go ahead and do this. Leave that alone on the left-hand side and add 3z to both sides. So it's going to look like this. 3z minus 48 plus 4i. Now we're going to square both sides, and you can do this in several different ways because we have 3 terms. Either you're just going to pair them up and use the formula, or you can kind of group these together, kind of lump, and then go from there. It's totally up to you. Now, when we square this, oh, by the way, before I do that, there's actually another way to look at it. This can be simplified somehow, right? How? Well, we can maybe separate it like this. And the square root of z squared can be plus minus z. And you can look at both. But let's say it's positive now. And this is going to be plus minus 2i. So it's going to be like 4i multiplied by z. So you can basically write that part as 4iz, okay? And now put the z's together, and guess what? I think this is going to be a better way to do it, even though you can still proceed with the square. But let's go ahead and do that. I think that looks like a better idea. So, and remember that the 4 comes from 2 times 2, right? So we get 4iz just by simplifying this expression equals 3z minus 48 plus 4. I think this is going to be better than squaring both sides because that introduces extraneous solutions. Okay, great. Now let's go ahead and bring the z's together, and let me see. I think I'm going to bring this over here and send these guys over there so that the real part becomes positive. So it's going to look like this. 48 minus 4i on the left equals 3z minus 4iz on the right-hand side. Later on, we're going to take care of z. Don't worry about it. So let's go ahead and now factor out the z here. This is going to give us 3 minus 4i. And finally, we can divide both sides by 3 minus 4i and 3 minus 4i so that we can isolate z, right? And let's go ahead and simplify this. Z can be written like that, but don't you want to simplify it a little bit? Probably by using complex conjugates. Multiply by 3 plus 4i and 3 plus 4i. This should do the trick, and you got to remember, if you multiply a minus bi and a plus bi together, you get sum of two squares, not difference of two squares, because I squared is equal to -1 again, right? So now let's go ahead and distribute this. 48 times 3, do you know that? It's 144. You should memorize it, 12 squared. And then 48 times 4 is going to be 192i. And then we're going to get minus 12i. Finally, we get minus 16i squared, which turns into a positive 16. Beautiful. And then these two guys will give us 9 plus 16, which is 25. Great. Let's go ahead and simplify this even more. This is going to give us something good, hopefully. This will give me 160. And these two will give me plus 180i. And all of that is divided by 25. We can divide both sides by 5. I mean the top and the bottom, I meant. Numerator and the denominator. If you multiply, divide by 5, you get 32. This will give you 36i divided by 5. So if my calculations are correct, this should be the answer for z, right? Okay, hopefully. I don't know if it's correct, right? You're going to check that for me, won't you? But we could also proceed with a slightly different version, because this could also be meant negative 4iz, and now we're going to get an entirely different solution from there. But go ahead and try it out, because I'm going to show you the second method real quick. Let's go ahead and take a look. Ready? We have the square root of z plus the square root of negative 4z. Now, instead of trying to square both sides and deal with that mess, why don't we just simplify firsthand, right? Notice that this can be written as square root of negative 4 multiplied by square root of z. And now, guess what? We can factor out the square root of z. Beautiful, right? It's the best. That's why it's the second method. But again, you're going to decide which one you like better. And I can write this as 2i or minus 2i. So why don't we just use 1 plus minus 2i and then 1 plus 7i. So from here, if you go with one of the solutions, let's just stick to one, can we? Because the other one is going to be super similar. You can go ahead and start with this and just simplify and see what you're going to be getting. There's nothing new about it, right? It's the same idea. Now, we're going to multiply by the complex conjugates again, but this time they're different, 1 minus 2i. But again, this is square root of z. Be careful about that. It's going to be 1 minus 2i plus 7i minus 14i squared, which is plus 14, divided by 1 plus 4, which is 5. This looks like a different answer to me. 15 plus 5i divided by 5. I probably messed up with the first method, because this gives me something super nice. And guess what? Once you get square root of z, then you can square both sides. So let's just write it down first. And then we're going to go ahead and square both sides. And guess what? You're going to have a single solution from here. Yes, there are two numbers whose square equals a particular number, but there's only one number whose square root is 3 plus I. Does that make sense? I hope it does. But anyway, z from here is going to be 9 minus 1, which is 8, plus 6i. Now, why didn't we find the same answer with the first solution? Because I probably messed up somewhere. And you know what? It could be because we did assume that it's just going to be the positive. Maybe we should take the negative. Or I messed up somewhere, and that's for you to find out. Sorry, I'm lazy. Too bad. And this brings us to the end of this video. Well, thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time in another video. Until then, be safe, take care. Don't forget to check out Cyber Math and aplusbi. And bye-bye.